Lesson, we are going to work on the properties of limits. Our goals here is getting familiar with properties of limits and use these properties to find the limit of some functions as the independent variable approaches a real number. In our previous lessons, we learned how to use a table of values or a graph to find a limit. If we look at the graph of y equals x2 minus 16 over x minus 4, we see it is straight line with a hole at the graph of the function. The hole indicates that x cannot be 4. In other words, if you consider f of x equals x2 minus 16 over x minus 4 and g of x equals x plus 4, when x is not 4, they are equal. That's why the graph of the function is straight line with a hole at x equals 4. When x is getting close to 4 from either side, f of x is getting close to 8. This means limit of x plus 4 as x approaches 4 is 8, which is the same as saying limit of the x2 minus 16 over x minus 4 as x approaches 4 is 8. Properties of limits. Suppose limit of f of x and limit of g of x as x approaches a exist. Then limit of f of x plus or minus g of x as x approaches a is the same as limit of f of x as x approaches a plus or minus limit of g of x as x approaches a. If c is a constant, limit of c times f of x is c times limit of f of x as x approaches a. Limit of f of x times g of x as x approaches a is limit of f of x as x approaches a times limit of g of x as x approaches a. Limit of f over g of x as x approaches a is limit of f of x as x approaches a divided by limit of g of x as x approaches a, provided that limit of g of x as x approaches a is not 0. The denominator shouldn't get close to 0. Limit of f of x to the power of n when n is a positive integer is limit of f of x as x approaches a to the power of n, and limit of nth root of f of x as x approaches a is nth root of limit of f of x as x approaches a if the root on the right side exists. These 7 properties can be stated verbally. Let's go over a couple of those. The first one says the limit of a sum is the sum of the limits. Or for the ratio, the limit of a quotient is the quotient of the limits if the limit of the denominator is not 0. If we start from very basic concept of limit, we say limit of f of x equals x, the identity function as x approaches a is a. Otherwise, limit of x as x approaches a is a, and limit of a constant function as x approaches a is the same constant. From 6 and 7, we can conclude limit of xn as x approaches a is a to the power of n, and limit of nth root of x as x approaches a is nth root of a if nth root of a exists. From these, we can find limit of some familiar functions. If p at x equals a polynomial function, an xn plus an minus 1 xn minus 1 plus a1x plus a0, limit of p of x as x approaches a is p of a. Later on we say polynomial functions are continuous, and for continuous functions, limit and value of the function are the same. In other words, limit of p of x as x approaches a is p at a, as we mentioned earlier. Limit of a rational function as x approaches a is the same as the value of the rational function at x equals a, provided that q at a is not 0. Again, rational functions are continuous when the denominator are not 0, and for continuous functions, limit and value of the function are the same. Let's consider f of x equals 2x3 plus x. Limit of f of x as x approaches 2 and f of 2 are the same. F of 2 is 2 to the power of 2 times 2, 16 plus 2, 18. Limit of 2x2 plus x plus 1 over x2 plus x plus 3 as x approaches 1 is f of 1, if we call this function f of x. F of 1 is 4 over 5, therefore the limit is 4 over 5. In calculus, finding limit this way is called direct substitution method. So we can use direct substitution method to find limit of some functions. Let's have a couple of examples. Use properties of limit and find limit of x2 plus 2x minus 3 as x approaches 5. If I want to use properties of limit, I say this limit is the same as limit of x2 plus limit of 2x minus limit of 3 as x approaches 5. Limit of x2 is 25. Limit of 2x as x approaches 5 is 2 times 5. And limit of constant as x approaches 5 is the same constant, and the limit would be 32. Or I can say x2 plus 2x minus 3 is a polynomial. If we call it f of x, limit of this polynomial can be found by using substitution method, which is f of 5. That is also 32. Let's use the properties of limit and find limit of x4 minus 5x2 plus 1 divided by x plus 2 as x approaches 1. Limit of division is division of limits when the denominator is not approaching 0 as x approaches a. Property number 5. Therefore, the given limit is limit of x4 minus 5x2 plus 1 over x plus 2 as x approaches 1. Limit of x4 minus 5x2 plus 1 is limit of x4 minus 5 limit of x2 plus limit of 1 as x approaches 1. Limit of x plus 2 is limit of x as x approaches 1 plus limit of 2 as x approaches 1. The addition and subtraction properties, and also the constant. Limit of x4 as x approaches 1 is 1 to the power of 4. Limit of x2 as x approaches 1 is 1 to the power of 1. Limit of 1 as x approaches 1 is 1. Similarly, limit of x as x approaches 1 is 1. Limit of 2 as x approaches 1 is 2. Therefore, this limit is negative 1. We could say we deal with a rational function. As x approaches 1, the denominator of the rational function is not 0. Therefore, the limit of g of x as x approaches 1 and g of 1 are the same. G of 1 is negative 1. Therefore, that limit is negative 1. Next example, limit of x2 plus x as x approaches 3. Using the properties of limit, we know this limit is square root of limit of x2 plus x as x approaches 3, which is 9 plus 3, square root of 12. Let's recap. In this lesson, we learned some properties of limit, such as finding the limit of addition of two functions is the same as finding the limit of each of them and add them up. Limit of division is division of limits, provided the denominator is not 0, as x approaches that number. And for some familiar functions, like polynomials or some simple functions, we just mentioned the meaning of continuity when the limit and the value are the same, and we use that property to find the limit of the function. Thank you.